Hello guys, welcome to my channel. This is Dr. Antoine, your coach in data analysis using R2. In this video, I'm going to tell you about checking data normality. Normality may be a big issue in data analysis, especially when you have small sample size. Before performing any statistical analysis, it is recommended to check whether your data are normally distributed. Choosing between parametric and non-parametric tests requires to check the assumption of normality. When you use parametric tests on data which are not normally distributed, results may be biased. That's why it is recommended to check whether your data are normally distributed. To check this, two methods are developed. You can check data normality using numerical analysis, or you can check it using graphics. I'm going to show you step by step how you can perform it in parametric tests like regression, correlation, analysis of variance. T-tests require that data must be normally distributed. If data are not normally distributed, non-parametric tests that do not have any assumption on data normality can be used. When you want to check this in R, two methods are used. You can check data normality using numerical values, or you can check it visually. In this video, I'm going to show you step by step how you can perform it, whether visually or numerically. Let's go. Okay, now we continue with our analysis. We continue to use our data set for indirect investment, which is a data retrieved on World Bank website. Now, as you can see, the first command is to import our data in our environment. This command, we have used this command in data preparation in the previous video. Here, when I click here, I'm just importing my data. This is to import my data in our environment. You see now our data were imported here. You see now. Okay, now as we already know our data set, we can just delete missing observation. Remember, I have shown in the previous video how you can delete missing data when we don't choose to replace missing data, whether by mean or any other method of imputation. Okay, now this is to delete our missing data because it is the continuity of the previous video. Okay, if you didn't see the previous video, you can just see it, but we continue in the same script. Okay, when you are checking data normality, the null hypothesis is that your data is normally distributed. The alternative is that your data is not normally distributed. To decide whether you accept the null hypothesis or not, you must check whether the p-value is less or greater than 5%. When the p-value is greater than 5%, now you conclude that your data are normally distributed. However, when you found that the p-value is less than 5% or 0.05, you conclude that the null hypothesis is rejected. That means your data are not normally distributed. Okay, you see this comment. This comment allows you to have value written not in scientific form, to have all zero. Okay, now we can begin with numerical method to test normality. Shapiro test is normally used, is the most used test in normality test. And here, as you can see, I just write Shapiro. This is the noun of my where I stored my data. This dollar here, it allows you to have access to the variable in your data set. Suppose that you have many variable you want to test. You have to use this dollar symbol so as to have access on one of the variable. Okay, now I learn this comment and I will check whether the p-value is less or greater than 5%. Now, as you can see here in the result here, you see Shapiro-Wilk normality test. You see now this test was applied on this data, and the p-value is this one. This is the statistic of Shapiro-Wilk, and this is the p-value. Now, as you can see, the p-value is less than 5%. As conclusion, we can say that our data that we are analyzing, if they are foreign direct investment, is not normally distributed because the p-value, as you can see, is less than 5%. We can check, we use another test so as to just to compare the results to see if we found the same result. Here we use this test, and I learned this test. You will see here, learn. This is DDA4, Common Globe, Small Love, Normality test. You see here, this is the statistic of the test, and this is the p-value. Here also, the p-value is less than 5%. Now we conclude with this test that our data are not normally distributed. Okay, we can continue and use the Jack-Bella test, normality test, this one. You can see here, and I execute this test here, run. As you can see, this one, also the p-value is less than 5%, and we can conclude that our data are not normally distributed. We can use another test, this one. Also, you can see Anderson-Darling normality test. The p-value here is less than 5%. Okay, we continue with this one also. Also, the test you see here, it is Jack-Bella test normality. Now you see that the p-value is less than 5%. And we can see to apply some of these tests, you need to install some libraries. This, for instance, Relief requires a library norm test. This one, to use this, you must install this norm test library. Okay. Now, all the tests we use shown that our data FDI we are analyzing are not normally distributed. This is numeric method to analyze normality of your data. It is important to perform this test because, as I told in this video, the choice of parametric and non-parametric depends on the result of this test. If normality is not respected, this the assumption is violated, that you must know that you have to apply non-parametric test, and if it is met, you use directly parametric test. Okay, now, as I told you, there is two ways of testing normality. The first one was numerical. Now, as you saw, we found the values where it is based on p-value, but you can also test normality visually. We use analyzing graphics. For instance, you can use this box plot. Let's show this. This is box plot. Right line, you can see you will see the result there. Okay, as you can see on box plot, you see there are some observations which are here. These observations you see here. Normally, when you see those kind of observations, this means that there are some outliers. Outliers are values which are very far from the majority of your observations. When you meet this word outliers, it means there are those observations which you can use box plots. This one, box plots. Here we execute. It's here learn. Now you can see here there are some observations which are far from this. Normally all observation would be inside of this, but now you see there are some when you want to increase the size, you can do this. Now you see normally the all observation would be inside this limit, this one, this, but now you see there are some observations which are far from the limit. And we can do also this one. This is the first test to test normality visually. You can learn also this one. This is another test. I do here learn. Remember, I'm testing normality. Now you see here the results. Here you see there are some observations which are far from this line. Normally, if data were normally distributed, all observations would have been aligned near this straight line. Okay, we can also use this test. You learn this comment, this one. You will see the result here. I learned this comment. Remember, I'm testing normality visually. Okay, you see also all these graphics shows observations which are far from this straight line. You see these observations, this one also. Why they should be aligned along this line? You see now they are far from this line, confirming that all tests performed, they indicate that our data are not normally distributed. When you can use also histogram. When I learn this comment, histogram, you see the result of this histogram, whether they would be well like this. It is not. We confirm that our data are not normally distributed. Suppose that you are asked to indicate those observations with outliers. This is the comment which allows you to have access to those observations with outliers. When I learn here, this is comment allows me to see the where outliers are, to get outliers, and this one allows me to identify the laws with or number of laws with outliers. When I run this comment, I execute this comment here, and when I run this comment, I will see all lines with the number of lines with or laws with outliers. All these numbers 10, 14, 26, 32, and so on. These are the number or the positions of countries with outliers. And when I want just to see those lines, to print those lines, to see those countries, I just execute this command. This one. You see, I see the country, and also this is because it is not too big. Let's see if I can. This one, I try to reduce this space. Let me see if I can have. No, it is not possible to get on. Normally you see, no, because let me try to see if I can reduce this. Okay, let's see. I'm trying to see if I can get each of the country, and okay, now it's okay. Now it's okay. Okay, now this is the number of the number of observation. This is the country, and this is the amount. You see, all these countries are considered as observation. That means outliers means observations which are far from the majority of observation, which has values which are far from the majority. And these countries are considered as outliers when you consider we consider the FDI of the majority of the countries. Now also it is another way of visualization of this observation is using this command. This is done with performance package. Now you have to install this package, and here you need to check for first outliers. This is the command to check outliers. This one, this. Now you see also we see observations where are located. These are the numbers of outliers. And with this command, this one, with this package, we can have access or we can print all those countries with outliers. When I see here, or I click here, I will see, okay, it is the same. You see now we have a country and we have the amount of foreign direct investment which is considered as outliers. This one, it is like what we have done with the previous comment. Okay, I think now you are able to check your data, if your data are normally distributed, or not. Remember, it is important to check whether your variable or your data are normally distributed, because the choice of parametric and non-parametric test depends on these assumptions. For all parametric tests, the assumption is that data must be normally distributed, and the null hypothesis we are testing is that our data are normally distributed. If the p-value is greater than 5%, we confirm that our data are normally distributed. If the p-value is less than 5%, remember, we conclude that our data are not normally distributed. I think this will help you in your data analysis, and all these steps we are doing must be written in your methodology. In the methodology, you have to describe correctly all tests you performed so as to choose this or this method or another method. Because as I told you, you will say that you tested normality and you found, for instance, that data are normally distributed, and that's why you choose to use parametric test. If they are not normally distributed, remember you have to choose non-parametric test. But the choice or the reason must be the violation of the assumption, or the reason is that you made the assumption of this test or another test is met. Thank you very much for following this video. I think it will help you in your process of data analysis. Thank you.